So, good morning everyone, my name is Claudio Pistida and I come from the Helmut Centrum Irion. Today I'm going to speak about the CO2 hydrogenation using metal hydrides. So, the CO2 methanation dates back to 1902 when Sabatier and Sanders first reported the possibility of hydrogenated CO and CO2 to form methane. Since then, this process has been developed and is applied to several different industrial fields. Now, the CO2 methanation can be seen as the sequence of two reactions. First, the CO2 interacts with hydrogen to form CO and water, and then CO reacts further with hydrogen to form methane and water. Now, this reaction doesn't occur easily by itself, but needs the presence of a catalyst. So if you look at this portion of the periodic table of the element, the gray element are those that have the highest activity toward the methanation process. Now, several metal hydrides may be used to carry the methanation of the CO2, and I will give you a few examples from the literature. The first example concerns the use of interstitial metal hydride for doing the CO2 methanation. This work was proposed by Kato Shunsuke and a co-worker and involved the utilization of a zirconium cobalt alloy with different degrees of hydrogenation. What they did is to prepare a flow reactor containing a different hydride bed, starting from the zirconium cobalt pure alloy to the zirconium cobalt hydride hydrogenate in different stages. What they find out is that the amount of CO2 and hydrogen converted to methane was strictly related to the amount of hydrogen contained by the alloy. This was explained by the fact that the hydrogen contained in the alloy could reduce the passivation layer present in the zirconium cobalt alloy, and thus allow the interaction between hydrogen and CO2 on the metal atom on the surface, and then to lead to the conversion of CO2 and hydrogen into methane. Another example of metal hydride utilized for the CO2 conversion to methane is the one of ionic hydrides, in the case sodium hydride and lithium hydride. Sodium hydride and lithium hydride were charged into a reactor pressurized with CO2. The reactor was kept at different temperature for different time, and what was obtained is the formation of methane. Now, the formation of methane is strictly dependent on the condition, and what we saw is the longer the time the hydride stay in contact with CO2, the higher the temperature, the more is the conversion of CO2 and hydrogen into methane. This, unfortunately, is due to the fact that lithium hydride and sodium hydride interact with CO2, reducing it to carbon, and then the reaction that we see of formation of methane is due to the interaction of carbon with hydrogen. A last example that I would like to bring to your attention is the use of complex metal hydride for methanation. The work that I select involved the use of magnesium iron hydride and magnesium nickel hydride to convert CO2 to methane. This work was carried out in the frame of our project by Dr. Maria Laura Grasso. So, as you can see here, magnesium iron hydride and magnesium nickel hydride, in absence of CO2 and the presence of helium, decompose while the temperature is increased at around 300–350 degrees C. However, when the heating is carried out in a CO2 stream, what we can see from the gravimetric measurement is that while increasing the temperature, we have a considerable increment of the mass of the material. Based on the X-ray diffraction analysis, we can say that this increment of mass is due to the formation of oxide species. Additionally, the MS analysis tells us that the formation of oxide is coupled with the formation of CO, hydrogen and methane in both cases. In conclusion, we can say that methyl hydride can be used for converting CO2 into methane, and that the nature of the methyl hydride influences the way the methanation occurs. However, we have to be honest and to say that this approach, the utilization of methyl hydride for the CO2 methanation, is an early stage of development, and more work is required for converting this process in an industrial scale process. Thank you for your kind attention.